let's look at number 4 through 7. We are integrating each of these. Number 4 and 5 are definite integrals. Numbers 6 and 7 are indefinite integrals. So just make sure that you are seeing the difference there. So for the first one, when we are integrating, we have just x on the bottom and just a number on the top. So whenever I have a number on the top of just an x, I'll just pull it out front. So I'm going to rewrite this as 6 times the integral of 1 to e of 1 over x dx. Now, when I integrate, I would have 6 times 1 over x. The integral of 1 over x is the ln of the absolute value of x from 1 to e. And now we do f of b minus f of a, so we're going to plug those in. We have 6 times the ln of the absolute value of e, which is just e, so you don't have to put those absolute value bars, minus 6 times the ln of the absolute value of 1, which is just 1, so you don't technically have to put those. So we have 6 times 1, because the ln of e is 1, and 6 times 0, so that cancels out. So we just have 6 times 1, which is 6. When you get to this point, you can put this in your calculator. You'll get the same exact answer. But since I knew what ln of e and ln of 1 were, I just went ahead and did that without getting out my calculator. But you'll get the same thing, and you will have a calculator on the quiz. For number 5, looking at this problem, we have a couple different options here that you could think of. Maybe you could do u is equal to x. Maybe you could do u is equal to x times the ln of x. Maybe you could do u equals to the ln of x. But only one of those is going to work. You can do the other ones, but it's just not going to cancel out what you need it to cancel out. So usually we look at a problem, and u is either the complicated exponent of e, or denominator, or a larger function. Since we have 2 functions in the denominator, we need to choose one to be u. The more complicated function is the ln of x, so u is going to be equal to the ln of x. So du is equal to 1 over x dx. So when we're looking at this problem, we have 2 to 4. I'm going to bring this 2 out front so I don't have to worry about it right now. And this is really 1 over x times 1 over the ln of x dx. Well, I have u is equal to the ln of x. So under here, I'm going to have u. So I'm going to have 1 over u. 1 over x dx is how I get du. So I have 1 over x and dx. I have those 2 things, and they're going to become du. So when I rewrite this, the 2 is going to stay out front. The integral, 1 over x and dx become du. I have 1 over u. And either you need to put the x's back into this problem, which is what I did on my paper, or you need to change your limits to u's. In that case, we would plug them in here, and we'd have the ln of 2 and the ln of 4. When you plug those into your calculator, you're going to get decimals. So you can put decimals on your limits. I prefer not to, so since I went ahead and changed those to u substitution limits, I would just put the ln of 2 and the ln of 4 here. That's fine, that can go there. That's just what I'm plugging in. Anything can go there, okay? Don't freak out. So when I am doing this problem, the next thing would be to integrate. So I have 2 times, I integrated, so I do not have an integral anymore. The integral of 1 over u is the ln of the absolute value of u, and I am looking from the ln of 2 to the ln of 4, and that's what I plug in. So I have 2 times the ln. When I plug those in, I have the absolute value of the ln of 4 minus the ln of the absolute value of ln of 2. And so that's plugging them in. So what happened here is that this was B. So I had F of B. So here's F, here's B. And then I had F minus F of A. Here's A. And I plugged that into F of A. And you can put all that in your calculator, or if you got decimals for those, if you got decimals for these LNs, you can also put those in there. You'll get the same exact answer. It just depends on the method you want to use. When you do put that in your calculator, the answer that you will get is 1.502. Okay, let's look at number 6. Number 6, if you were in class already, I told you to change this problem, but if you haven't seen it, this needs to change. Number 6 should be x squared minus 3x plus 1. That needs to be a 1 there. So if you haven't changed it, go ahead and change it now. Okay, it won't work. The problem won't work out if you don't do that. So looking at this problem, we have two things. We have on the top and the bottom, they have different, or they have the same powers. So a U substitution isn't going to help because when I take the derivative, they're not going to match. So this is a long division problem. You will have a long division problem on the quiz. So we are dividing x squared minus 3x plus 1 by x squared plus 1. So the first thing to do is look at the first terms. We have x squared and x squared. To multiply, what we multiply x squared by to get x squared is just 1. And then we distribute that out. So we have x squared times 1, which is x squared. And we have 1 times 1, which is 1. So you can put that under the 3x, or I would go ahead and line it up with its like term, which is over at the end. Our next step is to subtract both of these. So the negative goes to both. X squared minus x squared cancels. 1 minus 1 cancels. And we have negative 3x left over. So this is minus 3x over x squared plus 1. So when we do that, after we long divide, the whole point is we take what we got on the top and we put that back in our integral. So we have the integral, we don't have any limits, so we need to make sure we have plus c at the end, minus 3x over x squared plus 1 dx. And when I look at this, I know that I can integrate 1 easily, so that's going to be 1 dx, and I'm going to leave that separately for now. So I'm going to have 1 dx, the integral of 1 dx, minus the integral of 3x over x squared plus 1 dx. Now this is a quotient, and we don't have a quotient rule in integrating, so what we need to do is pick a u. So u is going to be what's on the bottom. That's going to be x squared plus 1. So du is 2x dx. Well, we have a dx, we have an x, but we have a 3 instead of a 2. Well, there's no way to get from a 3 to a 2 by multiplying by a whole number. So I'm just going to move the 3 out front because it's a number, so it doesn't matter. It is not useful to us, so I'm going to move it. So we have a 3 there. We do need a 2, so I need to put a 2 in, which also means I need to divide that 2 out. So this becomes the integral, sorry about my computer. This becomes the integral of 1 dx minus, we moved the 3, so 3 over 2 integral of 2x dx becomes du. X squared plus 1 becomes u, and that's on the bottom. And then we can integrate this. This becomes x minus 3 over 2. Integrating 1 over u becomes the ln, the absolute value of u, plus c, because there are no limits. So we need to put our x's back in, x squared plus 1. And that's our final answer. Last one, let's look at number 7. Number 7 is also a case where we need to long divide. Since 7, we have x squared on the top. When we take the derivative of that, we would get 4x plus 7. And that does not match what's on the bottom. So u substitution is not going to work. And especially the derivative of x is 1, so that's not going to substitute for what's on the top either. So we are going to do long division, 2x squared plus 7x minus 3. And we are dividing x minus 2. So when we do this, we have x times, we need to figure out what we multiply x by to get 2x squared. Well, we need another x, and we also need a 2 in front. And then we distribute that. So we get 2x squared minus 4x. Okay? And then both of those are subtraction. So that goes to both. 2x squared minus 2x squared cancels. 7x plus, that change sign, 4 is 11x, and we drop down the 3. So we have minus 3. So we are looking from 11x to get to, or from x to get to 11x. Well, we can do that. We can multiply by 11. When we do that, we'll get 11x minus 22. We combine those, it's going to be subtraction, so these cancel. Negative 3 plus 22 is 19. We can't go from x to 19, so that's our remainder. We have plus 19 over x minus 2. So this becomes our integral, 2x plus 11 plus 19 over x minus 2 dx. 2x, I can integrate easily, add the exponent, divide by that number. 11, I just add an x. This is my quotient, so it's going to be a little bit different. So I have 2x plus 11 dx plus, I'm going to move the number out front, 19 times the integral of 1 over x minus 2 dx. Now, you can integrate right after that green line if you want, but I'm just showing all the steps. So you technically don't have to show this step. You can go straight to integrating, which is 2x squared divided by 2 plus 11x plus 19. 1 over something is the ln of the absolute value of that something, because the derivative of what's on the bottom is on the top. And this is an indefinite integral, so we have to have plus c. So this is x squared, since the 2's cancel, plus 11x plus 19 times the ln, absolute value of x minus 2, plus c is our final answer for number 7. And that's it for these 4 integrating problems.